In this video, we will be covering the basics of specific heat. We'll be showing you the specific heats for certain materials such as iron, the equation for specific heat, and how to convert temperatures like Celsius to Kelvin. Imagine this scenario. You place a pot of vegetable oil and a pot of water on the stove. After 5 minutes, you measure the temperature. The oil is much warmer than the water. Why is this the case? Very simply, specific heat is the heat required to raise the unit mass of an object 1 degree. In practical terms, this means that the substance with the higher specific heat require more energy to warm up than those with lower specific heats. Take the scenario above. The specific heat of vegetable oil is 1.67, and the specific heat of water is 4.18. This means that it takes less energy to heat the oil. The specific heat equation is mc delta T. M stands for the mass, so you input the mass there. C is the specific heat, so you put the specific heat of that specific body in there, and then the delta T is the change in temperature.
In order to demonstrate how specific heat can affect real-life situations, we're going to run a short experiment. First, we'll take half a cup of olive oil, then we'll take half a cup of water, and we'll place each of these substances in their own pot. Now, after we do this, we're going to turn them on each to the same heat for a period of 3 minutes, and we're also going to measure the initial and final temperatures. Then, after we do all that, we're going to use the data to evaluate the results using the Q equals MC change in T equation to show how specific heat affected the results. Now that we have the data, we need to know the specific heats of the substances so that we can use the specific heat equation to determine if the experiment was successful. As we can see here, the specific heat of olive oil is equal to 1.97. The specific heat of water is, of course, equal to 4.19. Now we can begin evaluating the results using the Q equals MC change in T equation. However, before we can begin to do that, we need to make sure that all of our data is in the correct units. First, we need to convert half a cup to kilograms, which is standard units used in the equation. We determined that half a cup is equal to approximately 0.133 kilograms. Now we begin to use the specific heats. Now that we have found M, which does not change for either of the substances, we are going to input C, which is the specific heat of each of the substances. For the olive oil, as we just found, it is 1.97. For the water, it's 4.19. So we input that for C in the equation. Now for change in temperature, we need to convert from Fahrenheit, which is what the thermometer was in, to Celsius, which is what the standard units for the equation are in. The initial temperature for the water was 72 degrees Fahrenheit, and the final temperature was 107 degrees Fahrenheit. So we convert each of these numbers to Celsius, and then subtract the final from initial to give us the change in temperature for the water. For the oil, we do the same thing, convert each of the numbers to Celsius, and then subtract the final from the initial. So for the water, we get that the temperature difference is 20.88 degrees Celsius, and for the oil, it is 44.44 degrees Celsius. So now that we have all three of the variables in the equation filled in, we can find Q. Now, in this experiment, Q is supposed to be equal because the heat that we applied to each of the substances is supposed to be equal. The idea is to show that despite the fact that the initial and final temperatures for each of the substances were different, that they had the same amount of heat applied to them. So the experiment shows that Q came out to nearly the same number for both the oil and the water. So what this shows is that the data is correct. The same amount of heat was applied, and even though the initial and final temperatures were different, using specific heat, we were able to resolve that and determine using the equation that the same amount of heat was applied.
The above example is a real-world situation, but by using specific heat in the heat transfer equation, we can now determine the total heat transferred into the oil and water. In order to use the specific heat equation, you'll need to know need to be able to make unit conversions. To convert Celsius to Kelvin, you need to add 273 to the given Celsius temperature. The specific heat materials are different. Some examples of that is aluminum, which has specific heat of 897. Water, on the other hand, has a specific heat of 4,180. Steam 2020 and ice 2060.
The freezing and boiling point is different for different substances. For example, aluminum has a freezing point of 660 degrees Celsius, while it has a boiling point of 2,519 degrees Celsius. On the other hand, water has a freezing point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. And it's different for every different type of substance.
Today we talked about the specific heat equation, specific heat values, the melting and freezing point, conversions of temperature, and the definition of specific heat. Share with your friends who need help with specific heat and answer the questions in the description.